In the last lecture, we have discussed about the law of definite proportions, where we have discussed about the percentage composition and proportions of carbon dioxide, and we had talked about the Proust's experiment. So now we will discuss further about the law of definite proportions. So let's see another example. Let's consider the water molecule, which is H2O. As we have said, water can have different sources. It can be produced from a chemical reaction in the lab, as well as it can be collected from natural sources. Now, if we see the mass ratio, mass of H2 by mass of O, or we can say mass of hydrogen divided by mass of oxygen. We will take the ratio here. So we have 2 hydrogen atoms in water. So it will be 2 into 1 divided by the mass of oxygen. There is only 1 oxygen, so 16. So the ratio comes as 2 to 16 or 1 to 8. Okay. So this is the ratio, and this ratio will remain constant for every molecule of water, no matter from where it is collected or how it is produced. The ratio of mass of hydrogen to oxygen in a water molecule will always be 1:8. Now let's see the percentage composition. Okay, so percentage of hydrogen. So 2 hydrogen here. The mass of 1 hydrogen atom is 1. So since we have 2 hydrogen atoms, we will have 2 into 1 divided by the total mass. The total mass is 2 plus the mass of oxygen, that is 16, multiplied by 100. So this is 2 by 18 into 100. So the percentage comes as 11.11%. The percentage of oxygen. So the mass of oxygen is 16 divided by the total mass, that is 18, into 100. So 16 by 18 into 100. So the percentage comes as 88.88%. Okay, we can round it off as 11% and we can round it off as 89%. Okay, so this is the percentage composition of water, which again will remain constant irrespective of the source. So now let's solve some numerical problems based on this law. So the first question is, carbon monoxide or CO is a component of car exhaust. If a 10-gram sample of carbon monoxide is found to contain 42.86% of carbon and 57.14% of oxygen. So there are a few questions. Question A is, what would be the percentage composition in 6.58 grams of carbon monoxide? Okay. And question B is, what is the mass of carbon in 10 grams of the sample? Okay. So let's solve. Question A. What would be the percentage composition in 6.58 grams of carbon monoxide? So we have discussed that in the law of definite proportion, the basic point is the percentage composition of the elements in a molecule will remain the same no matter what is the weight or how much amount we have or from where we have collected. Okay, the percentage composition will always be the same. So, doesn't matter how much weight of carbon monoxide we are taking, the ratio of carbon to oxygen and the composition will always be the same. So, the result of the first question, that is what would be the percentage composition in 6.58 grams of carbon monoxide, it is a trick question. The answer is the percentage of carbon and percentage of oxygen will remain same. Okay, that is 42.86% of carbon and 57.14% of oxygen. So, even if the sample is 10 gram, then also this will be the percentage. Even if we are taking 6.58 gram, then also the percentage will be the same. The second question is, what is the mass of carbon in 10 grams of the sample? Okay. So, percentage of carbon was given as 42.86%. Okay. So, this is the mass of carbon in 100 gram sample, right? So, in 10 gram sample, mass of carbon will be equal to 42.86 divided by 100. Since this was in percentage, we have to divide it by 100 multiplied by 10 grams. Okay. So, the answer comes as 4.286 grams. So, this is the mass of carbon present in 10 grams of the sample. Now, there is a third question which says, what is the maximum amount of carbon monoxide formed from 50 grams of carbon and 57.14 grams of oxygen. Okay. So, let's say we have 50 grams of carbon and 57.14 gram of oxygen. Now, in the original question we had seen that this was the percentage composition. That means in 100 gram of the sample, there will be 42.86 gram of carbon and 57.14 gram of oxygen. Okay. So, we have 57.14 gram of oxygen here also. So, 57.14% of oxygen combines with 42.86% of carbon. So, we can say that 57.14 gram of oxygen reacts with 42.86 grams of carbon. So, here also 57.14 gram of oxygen will react with 42.86 gram of carbon, and so here carbon left will be 50 minus 42.86 grams, okay, which comes as this many grams of carbon will remain unreacted. Because for reacting this many grams of carbon, no oxygen is left with us. So, only 42.86 grams will react with oxygen, and the amount of carbon monoxide formed, the maximum amount of carbon monoxide formed will be 100 grams. Okay. So, we have done this one example. Now, let's see another example. So, the next question is 6.488 grams of lead combines with 1.002 grams of oxygen to form PbO2 or lead peroxide. PbO2 can also be produced by heating lead nitrate and it was found that the percentage of oxygen in PbO2 is 13.38%. Prove the law of definite proportion. Okay. So, what is the question? 6.488 grams of lead combines with 1.002 grams of oxygen to form lead peroxide. So, lead peroxide can also be produced by heating lead nitrate, and it was found that the percentage of oxygen in lead peroxide is 13.38%. Prove the law of definite proportion. Okay. So, when we were preparing lead peroxide by the heating of lead nitrate, then the percentage of oxygen in lead peroxide was found to be this. So, now we have another method where the weights are given. So, let us calculate the percentage composition from these weights. So, what we are given with? We are given with the mass of lead, which is 6.488 grams. Mass of oxygen is given as 1.002 grams. Therefore, mass of PbO2 will be equal to the sum of both of them. So, 6.488 grams by 1.002 grams. So, this comes as 7.490 gram. Okay. This is done by the law of conservation of mass, that is the mass of the product is equal to the total mass of the reactants. So, 7.490 gram is the mass of PbO2. Now, we will calculate the percentage of lead and percentage of oxygen. So, percentage of lead is equal to, what was the mass? The mass was 6.488. So, 6.488 divided by 7.490 into 100, which is equal to 86.62%, and percentage of oxygen is equal to 1.002 divided by 7.490 into 100, which is 13.38%. Okay. So, we can round this off to 87%. We can round this off to 13%. So, now we have proved that by this method also percentage of oxygen comes as 13.38%, which was observed from the second method also. So, we can say law of definite proportions is proved. Okay. So, we have studied about the law of definite proportion in this lecture. In the next lecture, we will study about its limitations and we will continue studying about the other laws. Thank you.